Hi, everybody. Welcome to our listeners, and thank you for being part of podcast number two, which is speaking about digital twin technologies and everything that is related to digital experience for the users and for teams in real estate itself. I know that the last three sessions have been fairly centered around design and around culture and around people. So we made this one particular session to focus on the operations and the facilities side of it, which is a hugely impactful and important subject that we must touch upon. Every time we're talking interior design, facilities and operation teams find themselves in a little bit of a soup, especially given the scenario and circumstances from the past 2 years about how efficiently and how diligently their space can be managed. To speak a little bit about the same with us, we have today Madhusudan from 4CT and Aparna from Zyeta. The last person that we have here with us today is Amit. Amit Prakash is a co-founder Zyeta, and he is the technical head and extremely technically and tactically sound brain behind everything that leaves our office on pen and paper. Welcome, Amit. While Madhusudan is the co-founder and the brain behind the digital twin technologies that they have to offer. Aparna here is our research and ideology incubation center on her own, leading our teams in the right direction every time a challenge comes up. Hi guys, and welcome to the podcast.
Thank you, Dhwani, for that rather good introduction. Thank you, Madhusudan, for joining us today on this podcast.
Thank you, Dhwani, for the wonderful introduction, and thank you very much, Aparna. Happy to be a part of the Digital Twin podcast today.
Great. So, as a brief, what we're going to talk about today is try to get an understanding for everybody listening to us, whether it's a designer or a leadership and organization person or a facilities person, on what it is that digital twin as a concept brings to the table for us in the real estate industry. There is a lot of talk and hoo-ha of late about creating digital twins and operating with your digital counterparts, but little clarity is there about the same, and more than clarity, there are very varying definitions about the same topic with everybody that we've spoken to. Just to bring a little bit of that clarity onto table, we have this session, and I'd love to begin with Aparna giving us a little bit of a brief and background about everything that she knows and she's heard about the same subject.
Thank you, Dhwani. To start off, I think I would try and break down as to what actually a digital twin is. There would be this misconception of a digital model and a digital twin, so I'm going to just say that both are very different. A digital model is just a digital version of a pre-existing physical asset, whereas a digital twin is a working model of a physical asset. It is the virtual integration of a working physical object. So it has various definitions. It was first coined in the early 2000s, and for different sectors there is a different definition for a digital twin. NASA was one of the first ones that came up with this definition of how they actually they had physical models of space capsules which were then interpreted as a digital twin, and how they used it for their own space study. And then we have it's big in manufacturing and mobility, where we have in manufacturing where they have a physical model of a manufacturing plant with its sensors and actuators, and that actually is again integrated in a digital twin of the physical model. And how so basically it's different definitions, but overall it comes down to the point of a digital twin works on data. It's rich in data. It works alongside IoT. It works alongside the physical object or an asset, and technology list of technology that would actually be beneficial and a huge advancement for the human population going forward. So it was actually it listed under Gartner as one of the top 10 technology services. So that's a brief about what a digital twin is.
Do you see relevance for digital twin picking up in the cultural context as an us here in India, and moreover so in our industry itself, right? We spoke about how it's being used in every industry in a particular manner, but in totality the concept remains the same. How do you see integrating it powerfully and valuably within the workplace interiors as a subject?
So as I mentioned, data is the driving force for a digital twin, and when it comes to a workspace or a building, as Madhusudan can actually correlate, when you feed data, everything that is generated, the analytics that is generated, when the data is analyzed, we will actually fall upon integrating it in a workspace, how the workspace can be planned, how the occupancy can actually help in giving in computing a layout that is operational, that is functionally optimal, that is energy optimized, in terms of it can actually help generating a future smart building. If the current building is not smart, but the data actually will help you in deriving a smart building for the future.
Fantastic. So when I hear you talk a lot about data and digitizing and sensors, right? The one thing that comes up over and over again as a theme to me is the fact that digital twin as a concept is more relevant on the facilities and operational side than it is on the design, look and feel side of it, right? So that's where the confusion in understanding the definition is. When you say digital twin, with the advent of metaverse as a subject itself, right? I know for a fact that, me included, a lot of people suddenly start to think if digital twin just means creating a parallel universe or a twin universe that is run by digital technology. And I know for a fact that that's not what we're talking about. So can you help us, Madhu, enlighten our listeners and myself on how digital twin works as a technology? What are the aspects of it and who exactly it benefits by inception?
So quickly, again coming back to the definition, like you said, it's been used in various contexts, right? So today, if you search in Google or even if you search in Wikipedia, the way the digital twin is represented is saying it's a virtual representation, right? But if it's just a virtual representation, it does not make a complete digital twin in our context. So what happens is, without the data, with the the digital portion of it, so it's not a digital twin for us, right? So that's where it has to be mixed with the sensors data. It has to be coupled with the assets, the kind of connectivity. Everything comes back onto a single platform. Then it forms the digital twin. So the way, in our perspective, in terms of the facility or the building perspective of the digital twin, we add in the platforms, right? So when we say a digital twin, so we build in a virtual representation of the space, the building. It could be the assets. Everything comes on to a virtual representation. And now we start feeding in with real-time data inputs, right? So we say the sensors. Now the sensors data is shown in live on the floor on the map, right? So that makes it smart. So we are also calling it as a smart digital twin than calling it just a digital twin, right? So because that's where the smartness is coming out. The smart building having a smart digital twin is with the sensors. So that's the sensor data where we're pulling in, and we clearly defining henceforth, saying that it's a smart digital twin specifically for a building level. And I would say that's the definition that I'll go with.
Thanks, Zoint. First and foremost, thank you for having me here. To answer your question, of course, a large majority of clients have definitely at least heard of digital twin, because this thing has been in news for quite a bit of time now. However, a large majority of clients do not exactly know what it is, or they do not know how to implement it, what are the challenges and opportunities that digital twin presents, and so on and so forth. But yeah, of course, in terms of many clients who have had some amount of experience with CMMS platforms, they have at least interacted with the predecessor technology of digital twin. Just like how evolution is a part and parcel of our lives in biology and in nature, in technology there's always an evolution. How we have descended from great apes, we humans have descended from great apes. Every technology evolves from a predecessor. Now, for digital twin, a very important predecessor has been CMMS platforms, which are BIM LOD 500 enabled. What essentially those platforms do is that they bring in facility management with a virtual three-dimensional model of workspace, and with that you can do different types of facility management activities. So from there, digital twins evolution has happened, where you have things like sensor fusion in place, which gives you much more real-time, user-friendly information, giving you much better control over the entire facility, as well as have a much easier control, therefore increasing your productivity and project lifecycle management.
Great. So what I'm understanding is, as designers, we create 3D models. We generally use our BIM platforms to do the same, to also integrate your MEP services, to integrate your HVAC services, and use that as a real-time model. For monitoring the data, we also use IoT and technology to feed all the models that have been created.
Absolutely.
To generate real-time data, right?
Absolutely, yes.
Fantastic. So tell us, what are the advantages or disadvantages of this concept, and how tangible or intangible it is to work with?
Yeah, so putting again, calling it as a smart digital building twin, like I said, right? So very specific to the building perspective, what we look at is seeing is believing. So the visualization of the facility components is the first most important thing for us as a facility manager, or as a business owner of the space itself. So once we visualize that, now it's all about data. So that's where we bring in a lot more data onto the platform, right? So with the data, like I can give you many examples of how the data can be used by a designer also to change the spaces if need be. So for example, the data of, say for example, a 10 packs meeting room, if more of 4 people are using a 10 packs meeting room every day, and while we are expanding our spaces, right, what if the sensors can push out the data saying, hey, you need more 4 packs rooms than a 10 packs room, right? So that starts helping the designer to put it in place, saying that how many 4 packs room can be built rather than a 10 packs room as well. So one is the space optimization. So the forecasting also is something which we can start predicting as per the workspaces, the workspace management, again, which is visualized using a 3D floor map, which was again conceptualized. So we're trying to use the same thing which was conceptualized. Then again, during the construction stage, we kind of changed a little bit based on the site conditions, and that's exactly what we use for the operational purpose as well. So that floor map is something which we use again and again, and that's where the operational point of view becomes much more important. So it's for the ease of the facility manager, for him to visualize and operate the entire systems in a better manner. One of the simple examples is, for example, if a VAV 24 is down. Earlier days it was in a like a table format where he had to go look around. We used to stick these stickers to these the VAV boxes, the vents, and we had to figure out which is the VAV 24, right? But now it's a visual map. Now I exactly know it is above this particular workstation the VAV 24 is. and this is working at this particular temperature, and these are the maybe there is a controller where the damper is not 100% open.
Right.
So it can be addressed to the pinpointing to the asset on a graphical level. So that helps really the asset as in the facility manager as well. So if you look at it, the other things which are adding on to these are your machine learning and the algorithms that are also prepared by the system itself. If there is a pattern which is created, and what if the machine by itself can learn this pattern and automatically apply a rule for that particular pattern, right? So those are again, like I said, the machine learning is a big subject by itself, and there's a whole lot of and when we say machine learning, it's not about again today we put one rule and it started off, but it's over a period of time it starts sampling the data.
Okay.
So as per the sampling of the data, it automatically starts learning, and that's the learning it starts putting into use as a rule. Right?
So instead of us sitting here as software engineers and we are defining our programs and writing code, your machine learning via digital twin practices writes its own code based on the pattern it has observed.
Yeah. So when it has to write its own code, obviously there's a little bit of algorithm that we put in.
Of course, yeah.
The whole point is, but the machine itself learns and does it. Yeah.
Right.
So that's another advantage of the digital twin perspective. Yeah.
But there was this one thing that I was asking you even earlier, right, about how the misconception about limitation of your digital twin technology or your digital experience being that you don't know how or how much manual integration is required. There is an understanding that this is good enough to manage your facility. One person is sitting and monitoring the whole space. What do you think about that, and can you enlighten us on the realities?
Surely. So like I said, what we're doing is we're doing a virtual representation and adding in the sensor data. But today, if physically something is blocked on one of these spaces, right, that is something which cannot be visualized as per the system. But due to analytics, it will tell you this could be the diagnosis for this kind of scenarios, right? But you cannot exactly point out saying that physically something is kind of wrong there. So obviously, yes, there are the way of understanding of the digital twin changes there, right? So what we are saying is I'm calling it a smart digital twin rather than just the digital twin, because in our case it's more of sensors data also that we are adding in there. So in a smart digital twin concept, what we are saying is however long you're able to at least get to the like a root cause analysis when you do and come to that particular point of the failure, and due to what it is failed is something which again physically if it is done, somebody has to go there and do it, right?
But the failure monitor will be displayed upon the systems itself.
Yes.
The repairing and the management has to be undertaken manually.
But once it's fixed, it will also come back on the system saying that it's up and running. So you also know the failure time. So one of the things, if you look at also, I would like to mention is using these datas, the failure datas. So we are building these models of, say, for example, what is the mean time between failure, MTBF we call it as, and mean time for repair, right, MTTRs, mean time to repair. So these values will start giving tomorrow, saying, for example, when a client asks, today we don't have those data. For example, he says, how long will it take for it to get repaired if anything fails here? And what is the failure rate? For example, over a period of 1 year, how many times do you think it will fail, right? So without having these MTTRs and MTBFs, we are not able to answer them, right? So today, using these models, those are some of the values also which we bring on, saying that we'll start building these MTTRs and MTBFs for your building, right? Specific to each asset, specific to each of your services that you're offering to the client as well, as into the workspace areas.
So it's like a predictive maintenance sort of a thing. Like if you it reduces the risk of mistakes, if I might say. I mean, if in a digital twin you can actually use these what if scenarios, right? And you can figure out, okay, what if this is what if this goes wrong, or what if this actually works, and you can actually see whether it works or not in the digital twin, and then we can interpret it in the physical model, in the physical asset object, and then we can figure out, okay, this works or this doesn't work. So it's like a continuous generation of data. The physical model will let you know whether, okay, whatever we inputted in the digital twin works or not, and then if that works, then we further generate it, we make it better. So there's always this continuous 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 maintenance, fault detection. I think all that is part of this entire digital, that which I think when it comes to a larger ecosystem of data, or of mechanical system or MEP, I think fault detection and FDD, as you had mentioned, that is actually very, very important when it comes to building management and facility management, because there's always room for error, or there's always something that could go wrong. But if we can actually predict those scenarios in a digital twin, we can make the physical model work better.
Okay.
I think that's
absolutely right.
Gist of what I tried you were saying.
No, absolutely. I think you brought in a good topic on FDD. So the digital twin with the FDD is again a very large subject. For example, I think again Aparna said, the biggest thing is the amount of data that is coming in, and how do we really analyze that data, right? So you're going to have tons of data. So that's where to organize the data, and one of the important things also is to how to organize the data hierarchically, right? So when a data is coming from a sensor, we need to tell it is coming from this particular hierarchy of the sensor. It belongs to a building, it belongs to a floor, it belongs to a zone. Then that has saying, there's something called as these standards that we use for tagging it. So project haystack we call it as, right? Brick schema. Now even a BIM model understands these brick schema as is. So once we start standardizing these data points, right, saying how the data is generated, and with that hierarchy we push it back to the cloud, and the tools, it could be a BIM or it could be a the FDD tool. Now everything is on the cloud. So over the cloud it automatically starts analyzing these data, and that is the analytics what we're looking for. Like again Aparna mentioned, saying that the FDD module wherein which based on a certain pattern you start understanding why the failure has occurred. Right? So that helps the facility managers to really start looking into, instead of spending say weeks together or even days together to analyze where the fault is, why the fault has occurred, they start understanding where exactly should I go and diagnose. That's it. Right? The information is in front of them saying what is the type of the fault, where it has occurred, and it may be due to these reasons, and this could be the diagnosis that you'll have to run for that.
Got it.
And it will be easier to assign that person's particular problem's subject expert to that particular problem.
Absolutely,
right?
yeah.
I mean, instead of all of us getting together and breaking our heads to figure out, okay, what went wrong, when we know that at this particular point there is a fault and that this is what we have diagnosed, that person, that expert can actually come and give his insight.
Sure.
And then everything runs smoothly as it was before.
So absolutely. So it makes
So it's a very wholesome experience. Basically.
Yeah,
it makes the life of a facility manager a lot more easier.
Yeah, you know who to go to for whatever's gone right or wrong. Basically, it doesn't have to always go wrong. Also, if it works completely well, that's also a very good advantage for all of us.
Your NTBF is 0.
Yes.
So just along the lines of that, right? Yes, it's making a facility manager's life very easy. But if I say at a project initialization stage, Aparna, initially you were mentioning about, and even Madhu, you were saying simulation of the whole space. So we're talking about prototyping one particular building or one particular model of the building to address what your design is going to look, and let it dictate the spatial design itself, right? How, as a workplace strategist, that's what I recommend. I don't recommend that a company goes into design, spatial design and spatial decision making before they have done their bit of research. So how do you think this particular piece plays a role in the same way, outside of our scope of space utilization studies, outside of our scope of observation studies and data analysis? What are the advantages that prototyping via digital twin brings to the plate or to the table?
So over here, when it comes to prototyping, it's usually made through simulations. And when it comes to, there is a very, even though it seems very similar that simulations are what garners a digital twin. Simulations is something that we actually they are run to try and forecast how a space would work, wherein a digital twin uses or simulations uses that the data that is simulated, and it will help us know whether that whatever the data is it working now. So when it comes, we can design a prototype from either a digital twin or from a simulation, or from a simulation. So the core of a digital twin is that it needs simulations. It needs a simulations tools and software. It needs IoT, it needs data, and it needs analytics.
Got it.
Simulation runs on analytics and a particular tool or a process. It does not need IoT. When you integrate IoT along with simulation, that is where you can actually build a digital twin of a physical model, and from there you will have a prototype. You can have a space prototype which has all these design planning principles, wherein you can feed the data about the company, how the workforce is coming in, what are the policies, how does it help in employee engagement, or all those are there are different sources for data when it comes to a digital twin, and all of that can be fed into to produce a prototype.
So creating a good combination of, say, your data and your organizational structure,
data itself
policy,
should be a accumulation of a lot of things which concerns the company as well as the workforce, as well as the space, as well as everything. It's a combination.
So in essence, yes, we're using the tool well for facility and operational management, but we're also saying that helping us monitor your space and helping us monitor how your workforce operates, what their working styles are, what kind of hours they work at, will also help you better define your culture, your policies, and your subsequent offices or spaces after that, right?
Sure.
This is fantastic. What do you think would be major design considerations, however, if as a designer, as a look and feel, like the space designer, had to think about incorporation of IoT and technologies and services to make sure that whatever simulations you want to run or whatever twin you want to generate is going the right way?
Sure, absolutely. I think that's a very good question, because I think if you look at Indian perspective today, we are moving towards rather very advanced kind of designs, right? So when we get into those level of designing, for example, today we're not having any false ceiling anymore, right? It's mostly open ceiling kind of offices today we're getting into. So when we're getting into the next advanced level of designing, also at least the industry is moving towards using advanced tools. Like, for example, BIM is not become a mandate today, but going forward, some of these models are going to become a mandate as well. So when we say a mandate, the reason is all the services have to come together, right? So, and that's where the input in terms of saying, for example, where a duct comes versus I can't place my sensor there, so I have to move my sensor, and the height between the sensor and the duct size. So I need to understand everything at the beginning itself. So while today, if you ask me, pre-digital twin era, our designs are very basic in terms of a lot of assumptions, right? Assuming that there's no duct here, assuming I have a clear height of so much, assuming this one, right?
And then overlapping the services after the design is created.
Correct. So that was a challenge. And I think we're shifting the era now, right? So the digital twin starts helping us to, visualize saying where the services are coming, where should I place my sensor, my type of sensor changes. For example, if I'm using a 20-25 feet diameter kind of a sensor, I may have to use only a 12 feet dia sensor in a certain areas, right? So the type of sensors will change. The coverage areas are changing, right? So my ceiling heights will change, and there are some obstructions in between. All of that is something which I can visualize as part of the tool. So it's very important for us to stay in the beginning at the design stage itself, to give those inputs in terms of where what has to come. Maybe there are two ways to look at it. One is to say, am I going am I going all the way implementing everything of IoT, or am I not going, right? But however, I would say, for all the clients, in fact, at the design stage, it's better to include.
Correct.
Better to say, tomorrow, in case if I want to do it, what could it be, right? So let's design the services based on assuming that we might have to implement.
Got it.
You may not implement it at day one due to whatever phasing it out, but I would recommend that let's include the design phase in terms of all the services of the sensors and everything to be a part of the design.
Got it.
So basically, the IoT has to be successful for a successful digital twin.
Yeah,
the infrastructure
absolutely.
is very important for a digital twin to actually run seamlessly and integrated.
Yeah, absolutely, and that happens to be at the design phase if it's good for us to start off with. So that's where we have to clap hands together there.
That's where that cycle also starts. Without the data, without the research back data, we will not be able to plan something. And once we start planning, it has to follow the flow of data that we already got from the beginning. So there has to be the IoT has to be integrated, like IoT design and IoT have to go, as you said, clapping hands together, they have to be together to form a happy clap.
That's great. Thank you so much. This is a very educative, very, very well broken down for everybody to understand. But before we end, I want to know what our users have to gain from adaptation of these kind of technologies or sensors and IoT, because most of what we've spoken about covers the facility, the operation and the designer side of it. But as a user of an office space, we're speaking so much about creating digital experiences. We're creating about making a user's life easier. We're talking about giving them apps for wayfinding and additional such entertaining requirements, right, from seat booking to anything else that we call. How can we make our users' lives easier?
There are user experience aspects of it, right from facility teams to many other teams. For example, you can definitely allocate seats, which may help the HR team. You can integrate these with your visitor management / room booking systems, and those things are easy to achieve. But the main game-changing thing is that if you have had good fortune of working with computers pre-internet era where computers were isolated, and if you had worked on operating systems like DOS, you will know that the modern day computing is extremely different. It has evolved drastically from those unnetworked or non-networked standalone things to networked, graphical, and many times three-dimensionally visualized interfaces. Essentially what it does is that it makes any user much more comfortable and productive in using any type of technology, and therefore it also increases the technology's adaptability. It definitely increases productivity, right? For example, no one was as productive when working on a computer which was not on network or which did not have a user interface. A digital twin gives you the right type of interface which we all human beings are used to. We live in a three-dimensional world plus time. Of course, we live in a three-dimensional world, and that's what this digital twin enables. We don't live on maps. We live in real worlds. We don't live in lines of words or a two-dimensional layout. Our world has height. It has a third dimension, and that's where digital twin brings in humongous amount of user experience and productivity growth for any of the user or any of the stakeholders who are there.
Right, and we also hear the increased capability to increase comfort of individual users from once you integrate the kind of technology to be able to control the lighting and the ventilation systems around you, and increasingly offices are now providing that, right? So maybe that's another added perspective of user experience itself.
Definitely. Individual control is a big aspect of digital twin. Individual control of your environment really helps you in being more productive and much more engaged with the company or the space that you're using. So that's a bang on point that you have made.
So the other use cases, say for example, again, mobile is one of the primary things of end user today. So everything is through a mobile. So using a mobile itself, something which as an indoor GPS navigation is something which he can look forward for.
Geospatial integration.
Yeah, indoor geospatial integration. Because what happens today, if you look at it, I think again the post-COVID era, if we can call it as, right. So one of the important things is there's a lot of new offices which have come up, and they don't know where is what and who's sitting where. There's a lot of understanding also the need of the facility, which can be given through the the digital twin model, which is already developed, and give that service back to the end user. So that is something again which is possible for them. So the other things are, say for example, we bringing in technologies like VR, AR. For example, VR is something which not only an end user, but also for a facility manager who can look around, saying what sensors are around, what is my occupancy, who's sitting where. So he can select what type of services he wants to look through and look at the real-time data which is coming in there again. So for an end user perspective, again, if you look at it, the AR technologies are really picking up as well. So AR is again similar to what we built on the digital twin. So he focuses his camera to a specific space where it could be a room, it could be a door, it could be anything, right? To a specific space, and it starts talking about that area. And it could also tell you, saying that hey, if it's a meeting room, it can tell you that this meeting room is booked for so and so long, and if you want to book it, please click here, and it takes you for that booking page directly. So that way it's become more interactive to the workspaces for an end user.
It's available at the tip, like it's in your hand, it's right there.
It's just there. It's like as good as you're talking to the building. Right. So it's like you're washing out to the building. Even your feedbacks are given in real time using these mobiles. As simple as QR codes is something which we're doing today, but we are also using augmented reality for giving those feedbacks also today. So that way end users can surely benefit a lot of it from the digital twin as well.
And by what you're saying, it seems like digital twin has been around. It's not been defined the way it has been defined. I mean, when we talk about room scheduling and figuring out whether the room is hot or cold. So when it comes to I think with the onset of IoT itself, a digital twin was the only way forward, right? I mean, it looks like, when it comes to buildings at least, when you have IoT, when you have sensors, the only outcome would be to generate a digital twin and then find out, okay, this particular thing is telling me this, and I'm going to predict it for my building to work well. So like how you said, the end user is talking to the building also talks back to us, talks back to the facility, telling that okay, so this person is using this, and the space is occupied, so maybe you should work around that. So I think it's like it's a two-way conversation. The building also is working. The digital twin is a conversation basically between the physical asset and the digital the real moment.
Absolutely. I think like the way Aparna said, it's like saying the digital twin is the robotic arm of the physical. The physical cannot talk. The digital can talk. So that's absolutely right.
I think when it comes to the end user, metaverse, hate it or love it, we are all part of the metaverse. If you have the mobile in your hand, you're already a part of it.
Absolutely.
And I think I've read somewhere that a digital twin is like a foundation of the metaverse. So it's a link between the physical world and the virtual reality world. So
got it. Great. So there is a little note that we wanted to understand about the use of and integration of virtual worlds within the lab spaces, because while we know that through COVID most of the offices were working remotely, lab consultants had to come into the office, right? And this is one area of challenge that we're seeing people increasingly try to improve upon. What is your take on it?
Yeah, so definitely IoT integration can play a big role in implementation of digital twin. See, there are constraints and opportunities both. Now, if most of lab equipments are not IoT enabled, if they are, then definitely they can be integrated. If they have IP addresses, definitely it can be integrated, but that's a project unto itself. It's not very easy to integrate lab environments completely and thoroughly into digital twin. However, the underlying infrastructure you can definitely integrate. You can definitely integrate the HVACs and the lighting and the if you have water flow system in your lab or a compressed air system in lab, all these things can be very, very easily be integrated in digital twin. But the lab equipments themselves are little too tricky to integrate in digital twin. And of course, there are other issues that comes up with remotely operating labs, like sensitivity of data and information and so on and so forth.
Got it. Which is why there's a resistance.
Yeah. So purely from physical infrastructure, definitely digital twin can play and plays a very, very, very big role in having any of the lab or R&D centers getting online.
Oh, super. That's great for us. Final note. What do you think is a critically do not do or a hindrance in implementation or usage of these kind of technologies, whether it's the client's perspective, whether it's a designer's perspective or the builder's perspective?
It's a beautiful question. First and foremost, as I was mentioning earlier, that digital twin is three-dimensional. If your workspace is designed by a BIM first company, that's the first hindrance that goes away. Because converting a pre-built environment into BIM is not very easy, though you can use certain technologies like point cloud and so on and so forth. It's not as easy accurately capture it as if you build your space BIM first.
Got it.
Secondly, if your workspace or your infrastructure does not have or is not designed keeping IoT in mind, retrofitting a workspace with IoT is again not very easy. So these are the two major hindrances. If you are designing your workspace using BIM first methodology and or rather design approach, and you are designing it keeping IoT in mind.
Thank you, Amit, for bringing out the client side the way you have. Thank you, Madhu and Aparna, for summing it up for all of our listeners and for ensuring that they're going away with solid clarity on the subject itself tonight. It was a pleasure to have you guys and such a seamless conversation we've had tonight. Thank you.
Thank you, Dhoni. Thank you.
Thank you, Dhoni. Yeah, thank you, Aparna. Thank you, Amit. Have a wonderful day.
Thank you.
Thank you.